Welcome to the workshop. Today we want to take a look at section 3.4, probability density functions. And the idea of this section is actually analogous to section 3.2, which we called probability distributions. So a probability distribution is for discrete random variables what the probability density function is to continuous random variables. So that's what we want to look at in this section. So this is the analog to the section 3.2 probability distributions. All right, excellent. So let's take a look at this section. So we've got a new definition, of course. A function with values f of x defined over the set of all real numbers is called a probability density function of the continuous random variable if and only if the probability that the random variable takes on the values between a and b, if this probability is equal to the integral from a to b of the function f of x. Okay, and in this case, let's see here, we should have, well, yeah, I believe in this case we should actually have negative infinity less than a less than or equal to b less than infinity, I think is what we require. But anyway, this is the idea. So this is actually essentially exactly what we looked at in the second example in section 3.1. We gave that graph and we looked at the area underneath the graph giving the probability. So this is exactly what we saw in the previous section already, okay? So hopefully that example even makes sense of this. So let's return to that example. And the graph that we gave, I give a very, very crude version of it, but it essentially could be represented by this particular function. It's a piecewise defined function. So between 0 and 10 gallons of gas, we have this function. Between 10 and 12, we have this function. Between 12 and 16, we have this one. And then everywhere else, it's 0, because what we want for these continuous random variables is we want these probability density functions to be defined on the entire real line. That way we can talk about integrating over essentially the entire real line. Now, most of that will go away typically because what we have is 0, right? Integral of 0 is 0. So we just ignore it and look at the smaller intervals. So we could actually calculate a probability based on this function for a fill-up requiring between 11 and 13 gallons of fuel. So let's do that. So the probability that we're going to need between 11 and 13 gallons of fuel, if we gave a good probability density function in our previous section, which we did, and this is the function for it. This is the explicit form. So this probability should be the area under the graph, which is, in this case, from 11 to 13 of our function. Now, since it's a piecewise defined function, it's defined differently from 11 to 12 and from 12 to 13. So we say, all right, we'll have to split this integral up so we can look at the individual pieces. So this is the integral from 11 to 12 of, let's see, that would be this portion. So 1/24 x minus 1/3 dx plus the integral from 12 to 13 of negative 1/24 x plus 2/3 dx. Now, I would encourage you to graph these if you wanted to, or I would encourage you to graph them and observe that it does look like what we had presented in the previous section. And these particular integrals, I assume that you're more than capable of calculating, with it being a polynomial, better yet, it's linear. These are rather easy to find. So a quick review of some calculus content will get you the evaluation of these integrals. Now, if you want to check your answers, you are completely welcome to do so. You can use a TI-84 to do that. I don't know that the TI-83s will, but the TI-84s, I believe, will. And you can look that up. Or you can use our good friend GeoGebra. GeoGebra has a computer algebra system calculator, a CAS calculator. So for these examples, yes, maybe you don't need to use this, but maybe in later examples you would find it very beneficial or very convenient to check your answers, because you should be checking your answers, not finding your answers using this, or at least you should be capable of finding your answers without using this. So what I want to do is I want to evaluate those two integrals that we were just taking a look at. Okay, so we can look at these two integrals. Integral from 11 to 12 of that linear function plus the integral from 12 to 13 of the other linear function. So, and we can do that. And it's very intuitive to do so using GeoGebra. What we want to do is we want to take an integral. So we type in integral. And as we type it in, it comes up with some options for us. In particular, what we can do is, if it's already in terms of x, which it is, we can use this third variation here. So we can type in integral, and if you were to click on that, it will give you, if you click on it, it will give you the inputs, and that works out really nicely. But typically what happens is you'll tab over or push arrow over to the right, and it doesn't work very well. In this case, it did. So I'm just going to use it since it did work well, and then go back and type in the function. So we have 1/24 times x, or simply x over 24. Let's see, minus 1/3, minus 1 divided by 3. And so 1 divided by, that's our function. And then we have the lower integrand, the upper integrand, and we hit enter. Bam, it tells us what it is. Except for, my apologies here, it's 11 to 12, not 11 to 13. There we go, 7/48. Excellent. So let's do that again, but I'm going to not use the automatic fill-in this case. So I've got integral, I can type the whole thing in, parenthesis. Our second function is negative x over 24. And then we need a plus instead of minus, so plus 2/3, 2 divided by 3. Get out of the fraction, comma, the lower integrand is 12, and the upper integrand is 13. Integrand, is that right? That might be what, that might, oh no, oh my word, why am I calling it integrand? That's not right at all. Those are our integral limits. The integrand is what we're integrating, whatever. I'm embarrassed, but I'll get over it. So we can calculate that as well. What's really nice is over here, it gave us sort of what the function looks like, shaded the regions, tells us the area. That's kind of fun. All right, so we can return to our notes. If you wanted to work these out, that would be good. You can use GeoGebra to help you. Find that it's 7/8 plus, sorry, 7/48, 7/48 plus 7/48, which is just 14/48, or divide both by 7 or both by 2 to get 7/24, and that's the probability. Excellent, and that's all that we needed. So that's all that I wanted to share for this particular video. We will actually continue on in this section discussing the idea of probability density functions a little bit more. So I'll see you guys back in the workshop very shortly.